not even recording. Okay, now I'm recording. So when we are going for specific applications like this deep learning things, that is when we have problems. So usually for general purpose programming, there is no problem. Python can just install Python and start programming. But for deep learning and things like that, we need TensorFlow. And installing TensorFlow can be a real pain to match all the versions. Even when there is a very teeny tiny mismatch, everything can stop working. So that is a problem. So I have been having that problem like a couple of days now. Still I couldn't solve it, but we can run things on Collab platform for the time being. But ideally I wanted to, because when you're running it on your local machine, it runs pretty much faster unless you have to use GPU. If you have to use GPU, that is a graphical processing unit or graphics processing unit, then it's better to use Collabs because they have the best GPUs, and the ones that come with our laptops, they are not very good. So anyway, last time we talked about, we created a very small desktop app, right? We created a desktop app. So do you guys know why we call this subject? Like today we are going to talk about deep learning, and even last time we talked about deep learning. So anybody, do you know like why it is called deep learning? Any idea? So this, I can ask these type of questions in the exam, to get your opinion, like within like 2-3 sentences, why it is called deep learning. So that is something that you should know, because all this image recognition and even this real-time object detection, everything is based on deep learning. So since we have been working for 4 hours last week, I mean, we worked for 4 hours, right? So you should have some idea why it is called deep learning. So that is something you have to keep in mind. Like we are using neural networks, and we talked about perceptron. A perceptron is the simplest form of the neural network. It just has only an input layer and an output layer, right? And it does not have any hidden layers. So just an input layer and an output layer. So that is the simplest type of neural network you can have. So what is the simplest type of neural network? That is the perceptron. So, but in reality, when you are modeling real life problems, that type of perspective, that sort of view is too simplistic. So we are going to have many layers, not just an input layer and an output layer. So we will definitely have an input layer and output layer, but in between there will be many hidden layers. So that is something, so you should check, you can check online, like what does it mean by deep learning? Like how many layers we should have? How many layers, what is the minimum number of layers we should have in order for it to be called deep learning? So because there are two types, there is shallow learning and deep learning. Shallow is the opposite of deep. So shallow learning, you can imagine it has a lesser number of layers. Deep learning, higher number of layers. So it's like that. So this is referring to the number of hidden layers. If you have a lesser number of hidden layers, that is shallow learning. If you have a higher number of hidden layers, that is deep learning. Okay, but exactly how many, like what is the boundary, what is the cutoff for deciding whether it's shallow learning or deep learning? That is something that you can check online, like at least how many hidden layers should be there in order for a particular neural network to be called a deep learning neural network or deep neural network. Okay, we call them like DNA, deep neural networks. So you can just check, you can just type on Google and see like how many hidden layers for a deep neural network. So if you just type it up and see, you can see that the boundary is 2 hidden layers. Okay, 2 hidden layers. So if you have more than 2 hidden layers, then it is usually a deep neural network. Okay. Do you get the idea? Anybody, any questions? So more than 2 hidden layers, you have deep neural networks. Some people sometimes like refer to even starting from 2 and above deep neural network, like some people say that, but yeah, just Google that and find out exactly what is the number of hidden layers that we should have in order to for it to be called a deep neural network. Okay. I might ask in the exam. Okay, so we can just go to the Google Colab platform, start working. So I'm going to start sharing my screen very shortly. So if you have any questions at any time, just let me know so we can discuss. Okay. So I'm going to first have a look at very popular classification for like it's for flower classifications, like different types of flowers, and we can even like same concept can be applied for classifying diseases of plants. Okay, diseases of plants. So I'm just going to do this. Machine is a little stuck. Let's just give me a minute. Okay? Okay, so I got a call from Dr. Shamila, so otherwise I wouldn't have picked it up, but I think she's also teaching some parts of this course, I think, probably. So from today, after today, I will not be doing lectures. So I guess I'm like, you know, we will not have to do anything related to deep learning again. So that's a relief. So anyway, I want to. This machine is not getting stuck all the time. Can you guys see my screen?
Yes, sir.
Okay. So, yeah. So I think you guys have your laptops with you. So we will, I mean, definitely, we cannot do this without a laptop. It's not possible to type all this thing in the phone. So we're going to need some libraries. So we are going to do some drawing and something to do with images and all that. So I have actually uploaded the flower database that I told you about to my GitHub page. So I will send you the link. So we will have to like import certain libraries. So the first one is matplotlib. So this one is for plotting purposes. That is like to drawing graphs and things like that. Okay. So it's matplotlib.pyplot as plt. And then we need numerical calculations, so numerical calculations. So we usually import this package, numpy, which stands for numerical Python. Okay, so that package. And then we have to go through the file system sometimes. For that, we need the OS. And then this other one is for dealing with images, PIL. Okay. And the other one that is needed for our deep learning activities. So that is TensorFlow. So what we are doing here is we are renaming it. So this is a long name. So we don't want to type it all the time. Every time we refer to it, it is quite long. We don't want to type. So we are just going to rename it for this session as PLT. So anywhere we want to refer to this one, we refer to it as PLT. And anywhere we want to refer to it as numpy, so we refer to it as NP. Okay. This one also, since this is quite long, we rename it as TF. Okay. So we have those, and we are going to also import. So inside TensorFlow, we are using. Sorry, this is from TensorFlow. From within TensorFlow, we import Keras. Keras is it's like the wrapper. It's like if we are dealing straight away with TensorFlow only, it is quite difficult. I mean, if somebody knows how to deal straight away, like only with TensorFlow, that is really good. But TensorFlow is more technical, and therefore, like a much simplistic view is given by Keras. It's like giving you more abstraction. Okay. By wrapping things up and giving you a much simpler interface. But TensorFlow can do much more than that, but it is not very, I would say, newbie friendly. Okay, so if you are a if you are new to this concept of deep learning, dealing with TensorFlow straight away might be a little bit daunting. But Keras, on the other hand, is more user friendly. It gives you a much simpler interface. Okay, that is why. So we, with the current installation of TensorFlow, we get Keras as well. Okay. So, and then we want to create a couple of layers for our neural network. So we also, from Keras, we import layers. Okay. And then, so this is using these layers, we are going to create some there are different types of layers, convolutional layers, dropout layers. So those layers are created using these layers, okay? That is inside tensorflow.keras. Okay. And we usually build our neural network models. There are two ways. One is the sequential way and the other one is functional. So say the sequential way is much simpler. So that is why we are using the sequential. So we import this class sequential from TensorFlow.keras.models, import sequential. Sequential allows us to create a sequential model. So in order to create a sequential model, we have to import sequential to our program. Okay, that is what we are doing. And then if you are dealing with zip files, then if you want to unzip them and things like that, this zip file module, it's very useful. So we are importing that one as well. And to deal with file paths, get this path link. Okay, that is for creating certain links to certain files and folders. Okay, so right now actually we are not connected, so we can connect. We can say connect when you click on connect to connect. Actually, I have used up my quota of GPU, so probably it will not let me connect to a GPU because last night I was using it and probably I used up all my quota. So let me see whether we can. Yeah, right now there is no hardware accelerator, so our calculations will be a little slow. If I say GPU and save, it's trying to allocate. And it says cannot connect to GPU backend because I have gone beyond my usage limits. So we'll have to go without GPU because since I have been using it for like 8-9 hours, now they are going to give the chance to someone else, and then let me like cool down for some time and then give me the chance to connect again. So because it's totally free, right? So just keeps rotating. So these calculations might take a little bit more time than we expect them to. So they're not even letting us connect to a TPU. So again, yeah. So we will have to be satisfied with the normal CPU. So we will just run this and we will rename this as flower detector, something like that. Okay. I mean, although we are using this for flowers, this concept can be applied in general for identifying anything. Okay, for anything. And then one other thing is yeah. So my GitHub. Yeah, it's right here. So this is where my flower data are. So usually, so this is my GitHub folder, GitHub account. So we can just download this as a zip file. So inside this data, you have a bunch of like different types of flowers, the images. And if you like look at them, they're just a bunch of flowers, and they are of different sizes. One other important fact is they are of different sizes. They are not the same size. So this is more generally applicable because most of the time when you download an image from the internet, it's not going to be like all of them are not going to be the same size. So that is the general case. So if you know how to deal with a set of images that are not the same size, then you can very easily extend that concept to other problems as well. Okay. So you have a bunch of flowers here. So we are going to get this, right click on this download zip and copy the link address. Copy the link address. And then we are going to get all that information to this platform. To this platform. So for that we use wget. Like if you guys have used, have watched Social Network movie, you might have seen that. Who's that guy? What's his name? Mark Zuckerberg. Like he's using a lot of these wgets. If you can remember, like he was hacking into the university server and getting all the images from the websites. So you can use wget to go through certain pages and download images. So here also I'm going to, in this case, I'm just going to give that link so that this will download. So, I mean, not download actually, yeah. In a way it's downloading from that server to this server. So I'm just asking it to don't check any like security certificates or anything like that. Then just to go ahead and use this address. Okay, just use this address. So this is the address that I'm using. So usually when you bring it inside this Collab, Google Collab, the folder structure inside Collabs is like this. Now we have some sample data that is always present. And if you click on this folder here with this up arrow, you will get the folder structure. And inside this folder structure, there is a folder called TMP, that is for storing temporary files. Because our session, this session is temporary, so we can download things to this temporary folder. But once the session is finished, Google is going to erase whatever we downloaded into this folder. So we had to do whatever calculation we want and download the results, because next time we connect, that data is not going to be there. Okay. So we are going to say get all the images from this web page and put them inside this output is where we are telling it where to put the images. Okay. Where to put the images. So we say inside the temporary folder. Inside the temporary folder, we are going to rename the file as flowers.zip. Flowers.zip. Actually, I think this is, let's try the lowercase. I can't remember exactly. If it doesn't work out, we will try the uppercase O. Let's try this and see what happens. Okay, so there is a problem with that one. So I think it's has to be still a problem. Okay, line 2. Oh, I think because I broke it into 2 lines. Okay, I will just have to. So I cannot do that. I think I cannot just break it into 2 lines. I'll probably put something like this here. Yeah. So it is going to download. So it downloaded everything. Just like altogether 219, approximately 219 megabytes. So it's very fast. And if you refresh this now, you can see there is this file flowers.zip under the temporary folder. So that is exactly what we specified. We said take these images from this location. So we put this backslash to indicate that we are going to the next line because we are running out of space. So next line, so we come here, output inside the temporary folder as the file name flowers.zip. Okay. So if you guys have any questions, just let me know. Okay. Let me know. Okay. Now this is zip file, right? Zip file. So we want to unzip. That is why we imported this zip file module. So using that zip file module, we have to unzip this. So I'm going to call it zipref. And then we use the zip file, and inside that there is another one called zip file. So this one is upper case. Now we have to give the path. What is the path? It's inside temporary folder. Okay. And then inside that the flowers. Okay, and we also have to say like which mode. So we are going to read from that. Okay. We are going to read from that. This R specifies the read mode. Okay, read mode. It opens the zip file in the read mode. Now we are going to extract everything. We are going to extract everything. Zipref. To extract everything, we have something called extract all. Extract all. And where do we want to extract? We will extract everything to this temporary folder. That's it. And then we close this zip handle. So zipref dot close. So now it is going to open this up, read everything and unzip and save it inside this folder. Okay. It's done. So now if you refresh this, you can see there is something called flowers.main, flowers-main. Inside that, we have the data folder, and inside that, we have our flowers. Okay. Okay, now we can check whether we have everything that we wanted inside this platform. So before that, we are going to rename. We are going to give the file path a name. So in this case, our file path is like where we have to observe. We have to check where the flowers are. So it is like under TMP and under flowers main and under like inside data. So we have to specify it is under TMP, it's under flower main, then it is inside the data folder. So that we have to specify. So we are going to give it a path name, name for the folder. We are going to call it data dir, that is our data directory. So we are going to use that pathlib module to create a path for that. To create a path for where? So this is pathlib.path. Pathlib.path. And we want to create the path to this folder here. So that is TMP, then flowers dash main, and then data. That is where we have our flowers. Okay. So we create that path. Now we can check whether we have our so we can create some image count. Image count. So now we are going to count the number of images. Okay. This length stands for the total length. And we are going to list all the flowers that we have inside that. Inside which one? Inside the data directory. And we can get a total directory walk using this function called glob. Okay. Now if we check how many roses we have, so we can check roses. Okay. Because now it will go to data directory, and inside that it will go to the roses folder, and then create a list of that whatever the number of roses, and then it is going to give me how many lines in that list. How many lines are inside that list? Okay. So that means how many roses? How many roses are there? So after it does that, I want the program to print the number of images. So we can just run this and see how many roses we have. Oh, I think there's actually, so we have to give the JPEG extension, like how many JPEG files. Yeah. .jpg. So here what happened is like it goes inside this data directory. So it goes inside this data directory, because if you just like just try to print this, you try to print this one, you will see it has all the flowers. That list contains like all the JPEG, whatever the file name is, it has to end with the JPEG. So all those files, I mean, this triple periods, that means there are more files than this, but it's not going to list everything because that's like 3,000 files. Okay. So for the time being, we can remove this one. We don't need that cell. Not this one actually. This one we don't need. I just wanted to show like what this exactly does. So this part, what it does exactly. So now we know like we have in total 3,670 flowers. Okay. So now this is going to list all the flowers inside the roses folder. That is this one, this folder. And then in that list, using this image processing, and this is a module that deals with images, this PIL. So we can open an image using that. For that, we have to give this name of the first rows as a string. So if we do this, it will open the first flower that we have. Okay. So there is one image that we have. So similarly, we can open the next one and the next one like that. So just make sure that we have what we want. If we go to the next one, that is number. Numbering in Python starts with 0. So the second one is number 1 actually. The 0 is the first one. Therefore, the second one is 1. So this is the second picture. So you can see they have different sizes. Like this one is like a square, but this one is more rectangular in shape, right? So we are dealing with the image set that has different dimensions. Okay. So similarly, we can. So we have another folder called tulips. So we can even just copy this one. It's only a small change. So we will go to this one. Just call it this one tulips. And just change this one to tulips. Okay, and then just like before, we can open the first one and the second one. So this is the first one. Oh, surely. Oh, not the roses. Should be the tulips. Uh, so now you get the idea. I mean, we don't have to keep on going like that. So now we have to just create our training set and the test set. So we have to train our model using these images. So we have to train our model. We have to divide the number of images into two main categories. One is the training set. The other one is the test set or the validation set, sometimes we call it. So that is our next task. We have all the images. Now we are going to divide it into two parts or two folders, okay, two types. So that split, what is the percentage that will end up in the test set and what is the percentage that will end up in the training set is decided by us. So we can use any percentage we want, but usually it's like 80 to 20. So like 80% training and 20% testing, or sometimes 70% training and 30% testing. Likewise, we have to divide the number of images between the training set and the test set. Okay. Okay. So in order to save time, just going to because I have tried this one for the beginning of the class. So I'm just going to copy this thing. Basically, we have yeah, right here. Now here we are going to divide this into two: training set and the validation set, or we can call it the test set as well. So those are the principles. Like this is how you implement, but in the theory you should understand. Okay, the theory you should understand. Like, what am I doing here? Okay, so here it says batch size. Batch size is 32, but why do we call it like batch size? That is because although we have, how many images do we have? We have altogether 3,670 images. But if we try to read all of these into our random access memory or the RAM in a single trial, then we might run out of RAM. So we will not be able to do anything else with the computer until this calculation is finished. So that is why we are going to read it in batches. Okay, we are going to read the flowers into the memory 32 by 32. So in batches of 32. That is how we are going to read it. So our batch size, like at any given time, we are going to read 32 images into the memory from the hard disk. Okay. And the image height and width are 180 pixels by 180 pixels. So you can see here, like initially they are not like that. They are not 180 by 180. They are of different dimensions. So that means later we are going to change. We are going to change their dimensions. so that all of them, for all of them, the height and the width are the same. Okay. So right now they are different from each flower, like one flower to the other one, the height and width are different. So we are going to change it. We are going to make both height and width equal to 180 pixels. Okay, that is like rescaling or resizing the image. So we can say here, the meanings of this one. So at a time we are reading 32. We are resizing the image. Whatever the height is, we are bringing it to 180. Whatever width is, we are bringing it to 180. And then we are going to, so this is the directory where we have all the flowers. So we are going to break it into 80% and 20%. 80% and 20%. And for validation of that, we are going to use 20%. And this subset, since this is the training data set, we are going to call it training. Okay. So this is just a random seed. Okay. Now you might be wondering, like, what is a random seed? Now random seed is like inside this, for example, if we go to this roses, okay. Now there are many roses inside this. So we have to, let's say, like there are 100 roses, then 80 of them have to go into training data set. 20 of them have to go into validation data set, likewise. Okay. So that kind of split has to be done. That kind of split has to be done. So how are we going to do that? We are going to do that randomly. So we are going to randomly select 80 from 100 and put it inside training, and then another 20 at random and put it inside validation. Okay. So for any random event to start, there should be a seed. Like if there is any random event, there should be a seed that sort of initiates the random process. This seed is what initiates the random process. It is given to the random number generator inside Python to start the random process of selecting 80 and 20 flowers. I mean 80% and 20% flowers. That is why we need the random seed. Now, if you use the same random seed as this, like if you use 123 also, then it is guaranteed that we will have the same, more or less same images in the training data set and the validation data set. Okay, because if the random seed is the same, most of the time the random numbers generated will also be the same. If you and I pick the same random seed, you and I will get the same random numbers. Okay. And then image size is image height and image width. That means all the images will be resized to 180 by 180. Batch size, that is, images will be read in batches of 32. Okay. So this is for the validation. Again, it's a similar thing. Subset validation. Now this time the difference is the subset is validation. Okay. This is subset is training. So you have to keep that in mind. Now, whenever we are doing machine learning or deep learning, when we have a data set, we are going to divide that data set into a training set and a test set. Training set has the higher percentage. The training set is used to train our model. And once it has been trained, we are going to check whether our model has been properly trained by giving it test files from the validation data set. If it is going to predict them correctly, then our model is good. So that is the idea. Okay, that is the idea. So we just have to press Control Shift, sorry, press Shift Enter. Okay. So now what does it tell you? It says found 367 files belonging to 5 classes. Now what are the 5 classes? The 5 classes are these 5. 1, 2, 3, 4, 5. Okay. So inside this, it found 3,670 flowers, and out of those, for training it is using this number. For training it is using this number, and for validation it is using this number. So how come it uses this number? Because we have specified that there is a split of 80% and 20%. 80% and 20%. Okay. Guys, again I'm getting. Okay, guys, now we are back. Now we have divided them into 80% and 20%. And then what are we going to do next? We are going to, now we can actually print the class names, like what are the class names? Because it says it identified 5 classes, right? Because it says here that there are 5 classes. So let's see like what are the classes it has identified. Okay, so what are the classes it has identified? So we are asking you to print the class names that it has identified. It says daisy, dandelion, roses, sunflowers, and tulips. Okay, those are the classes that have been identified within that data set. So then we are going to use, or we are going to draw them and see like, okay, what are the, like just to have an idea, like what kind of images do we have? Okay, so we are going to print like 10 of them. Okay, let's see. Now this is I told you like we are using that plotting module matplotlib. So this is how we are going to plot this thing. Okay, so we don't have any axes, like we are not going to print the axes like x and y. We are not going to do that. So right now we don't need this part. We are going to do it up to this. So we are going to create a figure of 10 by 10 size. That is the figure size. Okay, and then from our training data set, we are going to take like, so this is actually, can you guys remember we talked about this for I in range 9? Yeah, validation split is same in both test and training. So yeah, once it gives you 20, because it's a percentage, right? It's a percentage. So specifying one of them is enough. So it knows the other one is 80. Okay, that's the idea. So if you specify 20 for one, the other one is, it knows that the other one is 80. Okay, So specifying just one is enough. Here, split giving it as 0.2 is enough, because it knows the if it is split into like one part is 0.2, then the other part is 0.8. Okay. So here I'm just going to print these images. So these are the images we have. So you can see like there are different images in different backgrounds, right? So it's not like we have like all of them in white background, or no, there is no real need like that. Now you can see they are in different backgrounds. Now here even some people are here, but there are some flowers here. Okay. So you just get an idea like what kind of images do we have. Okay. Okay. So when it says go from like for I in range 9, that means it goes from 0 to 8. Goes from 0 to 8. Okay. 0 to 8. So 0 to 8, there are 9 numbers, right? So for those 9, you have these 9 figures. Because this whole figure size is 10 by 10. Whole figure size is 10 by 10. And you have drawn 9 images inside. Okay. So this IM show for showing the image. It means image show. IM show means image show. It is just like if you just keep it like this, it is going to give you some description. See, add a subplot to the current figure. Now it will give you the information about how that function works. Okay, how that function works. And the title is taken from the class names. What are the class names? Class names are these. So the titles are taken from the class names. See, plot title, class names. So we are going to give the class names as the titles, but the axes are off. We are not going to like put any tick marks to the x-axis or y-axis. No, there is nothing like that. Okay. So that is how our data look like. Then we have some this one auto tune. This is for efficiency of the system. Okay, to increase the efficiency of the system. Like I will tell you. Let's start a little bit. Because every time we call the images, it has to load everything from the hard disk again. But once it has called them to the hard disk, it is going to store it in cache, so that it does not have to load everything all the time. Okay. So that is the way to make things faster. Okay. So these shuffle 1000, like if you bring it here, if you keep it like that here, it's going to tell you like what it does. I didn't load this time. Here. You can just basically just check for this prefetch. This is one. If you want to know more information about this, copy selection, and then just search for sorry, not this one. Okay, it's just still coming. Yeah. So it is going to tell you like what does TF data auto tune do? Okay. This is prefetch. So that is one thing we are using, prefetch. Prefetch means like now you are going to bring some images from the memory, and like let's say you are bringing 1,000 images from the memory, but you haven't started processing on them yet. So let's say from 500 to 1,000, nothing has been done, but from 1 to 500, certain activities have already started. 1 to 500, certain activities have already started. So that means like once those activities end, you have something in stock. So whatever the activities, whatever pre-processing activities that needs to be done, once they have finished, that those pre-processing activities don't have to wait until the next set of images come, because they have been already prefetched. Prefetched means they are just keeping in reserve. Okay, whenever the pre-processing finishes, we are ready here for you. Yeah, so we are going to bring it from the hard disk to the memory before they are needed. Okay, before they are needed. So that is prefetching. Okay. So those are like certain strategies to improve the performance. Okay, to improve the performance. So it's like data performance. It's under data performance. Tells you like what exactly do they mean, auto-tune. And this prefetch. Okay, buffer size is auto-tune. So this auto-tune value is provided by the system. This auto-tune value is provided by the system. Okay, and whatever that value, then it is going to set it to the buffer size, and then that amount will be fetched from the memory. Okay, so the same thing. And for our training data set, we are going to do some shuffling. I will do some shuffling, but for the validation data set, we are not going to do any shuffling. There is shuffling for this one, but not for this one, because there is no meaning in shuffling the data for, I think I mentioned that last time as well. We shuffle this data for the training set. Okay. And at the same time, this will be remained in the cache, so that every time we don't have to bring when it's needed, it is retained inside the cache. Okay, so that is the meaning of that. I think you guys have an idea like what this does. So see, prefetch data set with 92 items. It says cache. The first time the data set is iterated over, its elements will be cached, either in the specified file or in memory. Subsequent iterations will use the cache data. See, that is the meaning of that. That means you don't have to bring it over and over again from hard disk to the memory. Once you bring it one time to the memory, it will be retained in the memory, so that you don't have to bring it again and again. Okay, use from the cache data. It's like this now. This cache thing works like this. Like let's say now you are going to a restaurant. Okay, you are going to a restaurant and you buy the same thing every day. You buy the same thing every day. Like they know that you, whatever you order is going to be, let's say, what are you going to eat? You're going to have tea and then some Chinese rolls. Okay, that is what you're going to eat. And the waiter, he knows. When he sees your face, he knows that you are going to order this. Now you have been ordering that same stuff for like 5 days. Next time, I mean, this might be an imaginary situation. By the time you start coming to the restaurant, that guy has already prepared it for you. So you don't have to wait. You feel like, oh, there is no waiting time. He has already prepared it. Why? Because he already knows, but because you have been asking for the same thing over and over again, the computer knows that. So the computer will keep it in a much easier location so that you can easily reach for that. Okay, that is caching. Okay. Because it will keep a tab about what you usually need. And then those usually needed, like frequently needed items will be kept in a location in memory where it is very easy for you to read. Okay, that is caching. Okay, so enough about caching. We will go back to our deep learning. So then we are going to start building our model. We are going to start building our model. So number of classes is 5. Number of classes is 5. Why? Because I mean, we have 5 flowers, right? 5 types of flowers. So number of classes is 5. And yeah, here we have rescaling. Rescaling means I told you like when we look at images, if you just open an image, like I'll show you, like let's say you have an image somewhere. This image, let's say. So you open that image. Okay. It's so slow. Let's say you open it using you open this image using this whole, yeah, notepad. Okay. You open it using notepad. That's that fine. It's just slow down a lot. Okay. Now it's coming. This is like really, I feel really guilty about this. I feel like I'm wasting your time. It's really this one. Yeah, this is not what I expect. Yeah, this has not been converted yet. So yeah. Yeah, this has all the location information. Yeah, but once this gets converted, I mean, you can see like these are like it's just a bunch of numbers actually, but there is some location information like who like what is the location and things like this, like copyright information and everything is here. You know, we can save the location information and everything. That's not what I expected to show you. So I just wanted to tell you like inside the machine, like if you read this image, it is given as a bunch of numbers that go from 1 to 255. Okay, goes from 1 to 255. So those numbers Like if there is a number between 1 to 255, 255 is the highest number. So if you divide by the highest number, if you divide all the numbers by the highest number available, then all the numbers are going to fall between 0 and 1 because you are dividing by the highest number. So all those numbers are going to fall in between 0 and 1. So that is the idea of this rescaling. Like we are going to divide all of them by, so in this case, we multiply by 1 over 255. Multiplying by 1 over 255 means you divide by 255, right? So that is the idea here. So that is rescaling. Rescaling, or we sometimes call it normalizing. Okay, sometimes call it normalizing. So see here, you get the description. So once you, initially they are in this range, but once you multiply by this factor, they are going to fall in the range 0 to 1. Okay, 0 to 1. So that is going to increase the performance of our calculation. Okay, that is why we are doing this normalization. Then what are we doing here? Here we have convolutional layer, 2D convolutional layer. Okay, so all the information is here, 2D convolutional layer. So what do you know about? I mean, we talked about this last time as well. So what do this mean? These numbers, kernel size, an integer or tuple of 2 integers, specifying the height and width of the 2D convolution window. That is the kernel size. Filters, how many filters are there? Now we are going to use 16 filters. 16 filters. Okay, that is going to use 16 different types of filters for finding different patterns. And it is going to use 3 by 3 matrix as a what? What is this? That is the filter size, 3 by 3 matrix. And you have 16 of them. Okay. Now there's padding. Like there's some different factors. Now padding is useful when you are reaching the end of a file. Like if you reach the corner of a image, how are you going to fill the pixels? Okay. Do you understand what I'm saying? Like, let me tell you what I mean. Okay. Now, if you take this image, now if I'm taking a 3 by 3 matrix, so it's like this 3 by 3, and it's going to shift from left side to the right side, like pixel by pixel. It is going to scan like this. It's going to scan like this from left hand side to the right, left to the right. So once it comes here, okay, then it is going to, let's say, go outside this like this, because it's 3 by 3, right? 2 on this side, 1 on the other side, then 1 on this side, 2 on the other side, likewise. A little bit of it is going to go outside. So how are we going to fill those pixels? So that is padding. So how are we going to fill those pixels when the filter goes outside of the image? Okay. Is it going to be black? Is it going to be the same color as this? So that is the padding. So that is what is specified here, padding. You just keep your say you get description, but you can do that. So activation, again, rectified linear unit. That is the activation function. I showed you guys like the shape of the rectified linear unit last time. Then we are going to do max pooling. That's again, we are going to, what is max pooling? Can you guys remember max pooling? Usually we divide into 2 by 2 squares and then get the maximum number from that pool. And then replace those pixels with the maximum number. Okay. See, even if we don't specify a pool size, the default is going to be 2 by 2. So even we just keep it like this, the default is going to be 2 by 2. Okay. So then we have another, so we have 3 convolutional layers, 1, 2, 3. Okay. After that, we have a max pooling layer again. Then finally, we are going to flatten it. Flatten means we are going to convert multidimensional image into single, like one-dimensional image. So all the numbers will be brought into one dimension. Then it is going to be forwarded into the dense layer. Dense layer is a layer where all the nodes are connected to other layers, other nodes, previous and subsequent. All the nodes in a given layer are connected to all the other nodes before and after. That is the layer before and the layer after. That is the dense layer. Activation is ReLU. And we can use number of classes, that is 5 here, 5. And here we can specify activation because this is a final one, right? So the activation we can give here. What is the, so we have more than 2, right? So we can give softmax. Softmax as the activation function. Okay. So once we do that, we can just run it. It's done. And then we have to compile this. Okay, we are going to compile this one. So the Adam is the optimizer. Loss is measured like this, the categorical cross entropy. And then how are we going to measure the accuracy, how accurate our model is, using the metric called accuracy. Okay. That means if we are given 100, out of 100, how many will we predict correctly? That is accuracy. Okay. So that is what we are going to use. So this will be compiled. Compiled, and then now only thing left to do is we have to run the model. Now before that we can get a model summary. Okay, we can get a model summary. I mean, just to get an idea like how our model looks like. Okay. I can only type here, then I can start. Trying to do too many things at the same time. It's being very harsh on me. Okay. So these are the parameters. So we have many, like huge number of parameters. You see in the dense layer, you have a huge number of parameters to optimize. Okay. So all of them are trainable. That means they can be optimized. All these are trainable. There is no non-trainable parameter. Because there are sometimes non-trainable parameters, parameters that have been frozen. Because we want to intentionally freeze them. Okay. But here we are not freezing any parameters, so everything can be optimized. Okay. all the parameters can be optimized. So for each of them, I can see the input file will be 180 by 180 by 3. That is 180 pixels long. The length is 180, width is 180. Then there are 3 color channels, RGB. Okay. Okay. So this is the input for this. Sorry, this is the output from this, from the rescaling. Okay. Now we just have to run. Now, how many times will our model go through all the data? How many times will our model go through all the data? That is the number of epochs. So we are now going to fit the model. Our training data is from the train DS. That is, we have already given a name. Train DS is here. Validation data set here. So we are going to give those data sets as input to the fit function. Training data set and the validation data set. And then how many epochs? 10. Now this is going to take some time. That is the problem. I mean, this should have been we needed something. So we will use this categorical process. Because last time also we used the categorical process. Can you guys remember? Because you have to know that like categorical cross entropy is for multi-class classification. Binary cross entropy is for binary classification when there are only 2 classes, right? You can remember, yeah, those are some facts that you should remember. Here we see loss is categorical cross entropy. And the activation is softmax. So we will use this categorical cross entropy. Categorical cross entropy. So we will stop this. So we stop that and we are going to call this categorical cross entropy. Yeah, just like last time. Okay, so we can run this one. Mhm. We have an error here. Incompatible shapes. Output shape. Why do we have compatible shapes here? Hmm. Let me just do the same one. I will have to change this a little bit. Yeah, this. Okay. Yes, this is a problem with the versions actually. I mean, this previous model that was done using a different version. I can see now here I have used a test directory and a train directory separately. You can see here there is a test path and a train path, and within that I have my 3 classes. But here it's different. Since I have 5 classes already, not divided as train and test, just 5 classes. And out of those 5 classes, I am randomly taking 80% and 20%. So this is the latest version. The previous one was a slightly lower version. So this is like the newest version of TensorFlow. So there are certain like different ways of doing it now. The terminology has been changed a little bit. So we cannot just here, that's why I tried to use the softmax, but when I use softmax here, it doesn't work with this type of loss. There was a mismatch in the data dimensions. So that's why I changed it back to how it was. But this seems to be working, and like if you look at this how it proceeds, you can see the loss is decreasing. Initially the loss is 1.2215, accuracy is 0.4891. But now you can see in the second step, the loss has decreased and the accuracy has increased. So that means we are good. If we have completely messed things up, then accuracy will decrease. But here the accuracy is increasing and our loss is decreasing. That is what is important. Okay. And we will see how well it can predict. Okay. The thing is, now this is quite slow because we don't have a GPU. So this is going to take some time. So the ETA is like, you can see 20 seconds. So here we have to wait for like for each round we have to wait for like 1 minute. But at the same time, you can see that the accuracy is although it is fluctuating a little bit, it is actually increasing. You look carefully at the accuracy. No, actually now, not the basic, I mean, the terminology is different. Like, for example, now if you look at the latest version now, the latest version of TensorFlow is 2.6. But like if we install from, if we just type something like, see, if we do something like this, Conda install from the Anaconda channel TensorFlow, it is not going to install the latest version. Okay, and if we use Conda install, not the Anaconda channel, if we install it using just like this, Conda install TensorFlow, then that is going to install another different version. And if we use something like the Forge, that's a different channel, like that is going to install another different version. So this, so now here also there is a mismatch, you see. Now for different versions of TensorFlow, there are different functions available. Now the function set that we used with 2.3 or 2.2 is not going to work with 2.5 or 6. So you have to be updated about the latest versions and the terminology of the TensorFlow libraries by looking at their website regularly. So if you go to the TensorFlow website, you can see like it is the, they have it's going, it will go there eventually. I mean, it's a little slow. Now they have 2.6, but like now if you go to one of their tutorials, like there is resources, and under that there will be tutorials and things like that. So learn ML educational resources. You can see now for 2.6 the function names and everything have changed. So the function names that you used with the previous versions, they cannot be used with these newer versions. So if you are going to use the functions that you have been using with 2.2, you have to stick to that set of functions. So you can't use one of that with another one from 2.5. They're not compatible. So that is what happened here. Like here, the moment I change this to categorical cross entropy, and this activation is softmax, there was a mismatch in the sizes of the matrices or the tensors. Then it gave me an error. But if I had been using the same function, so you can see here the layers.experimental. That is not the way we created the model last time, right? Last time we created the model using this model.add. So these are for previous version. So they are producing different types of, so you can see here we are giving 3 by 3, but here they are giving only one number. And there are slight changes in the output as well. So you have to go with this same set of terminology if we are using this version, this particular version. But usually there is backward compatibility. So you should be fine even if you use this set of names. I mean, this is completely fine still. This is only like, I think 6 months, 8 months old. But everything is changing so rapidly. That is why. So you have to keep yourself up to date by being carefully vigilant about their website, like what are the latest tutorials and all that. That way you get to know the latest terminology. Okay, so that's what I wanted you to know, because here we are using how many classes? 3 classes, activation, softmax. So this worked for this one, but the same one didn't work for the current, like the one that we did today. And it comes all the way from the top, because we have been using the function set of the latest version of TensorFlow. That is why suddenly changing this one from this number of classes and adding activation equals softmax, it didn't work. Because things have to come from all the way from the top. Then we should have been using this structure from the very beginning. Then this would have worked. But at the top, we are using a different structure. So at the bottom, it won't work. If we just suddenly switch to this format, it will not work. I think you understood what I said, like the person who asked the question. Hatum, do you understand what I said?
Yes, sir. Thank you.
So, but with the newer version, I think things are a little easier. Things are a little easier. The only thing is you have to follow everything from you have to use everything from the latest version. Because earlier we have to divide the whole image set into a test set and a training set. And within that, we have to have 5 different folders or 3 different folders. But now we don't have to have a training folder and a test folder. We just have to have only, like, let's say 5 classes, just 5 folders. No, we don't have to divide them into train. I mean, we will do that, but we don't have to create a file structure in the computer according to a training set and the test set. We just have to have only the folders for the whatever the classes we have. 5 classes, 5 folders. Then once we give the input of that, like once we give the images of those classes as input, then using that that function we have here, image data set from directory, we can straight away divide it into validation and training set. But this function was not available in the previous versions. This .image dataset from directory was available like from 2.2 and upwards. This was not available in 2.0, for example. In that one, there was a function called flow from directory. Flow from directory. That is the one we used in this one. We use something called flow from directory. See, flow from directory. But in the latest version, they have image dataset from directory. I think probably we have, we have 2 more rounds to go, 2 more epochs to go. After that, we should be fine. But this is a really interesting field, like so many applications. If you get to know about this, so many applications. Today my computer has slowed down a lot because I did not close this lid for some time now. It has been a couple of days and it has heated up and too many tabs open. But whenever you have time, like, I don't know whether you have time now, but go to that channel, the YouTube channel that I told you about. His explanations are really nice. The code basics channel. He's a really nice teacher who can like show you how it's done. Like this code basics. This channel. Yeah, this machine learning for beginners. And there is a separate data science series. Oh, see, image analysis and everything. So like very recent ones. They're not very old because he updates them regularly. Actually, in collab, it's very difficult to crash something. They have backward compatibility. Now this collab platform has been created for people who are not interested in dealing with the installation problems. So they have all the versions installed. So you don't have to worry about the versions a lot. But the thing is, you can't mix them. Like if you are using a particular version, use all the functions from that version only. Then it will detect that version and use everything from that version. But if you use a function from 2.5 and then use another function from 2.2, then it's going to clash. Then it will give you an error. That is what just happened like a couple of minutes ago. That is what happened. Okay. So, but if you are using the functions from the same version, it should be fine. But always try to use the latest version. But even the old ones, once you go through a couple of tutorials, you will know the corresponding counterparts in the newer version. So it should be okay. So just go through their tutorials, the ones that they have given in TensorFlow. Just go to that website and they have some really nice free tutorials. You guys know that TensorFlow is totally created by Google. So Google have the Google on the collab. So they just have everything. But the Python guys, they are like little slow. Now, for people who are interested in doing research on this, like diseases, plant diseases, this series is really nice. This potato disease classification that just guides you from the very beginning to the end. Okay, now our calculation is finished. So we will just go back to that one. Okay, now we can just check how accurately it can predict. So accuracy and validation accuracy, the loss and validation loss. So we can save them from this history, because we saved everything to this history, right? Can you guys remember? History equals model, that's what we ran. So all the information, verbose information is saved inside this history variable. So from that, we can get some information out. Get some information out. And then plot them. You can plot that information. So you can see here, now here we have taken from history, we have taken this tag called accuracy. Those accuracy values saved into this variable ACC. Validation accuracy values saved into val underscore ACC. Similarly, loss and validation loss, these values have been extracted from this history variable. History variable was created here. You can see here. So as the model was being fitted, everything that it gives as output is saved inside history. From that we get this, extract these values. Okay. Then we plot the for the validation accuracy, the one for validation accuracy and training accuracy, and validation loss and training loss. So we can see here our training accuracy is increasing. It's like almost 1. So if you look at this, see towards the end, it's like 0.9986. It's like almost 1. But at the same time, our validation accuracy is not that great. It's like it's good, but now this is okay. Now validation accuracy is somewhere around 0.7 and our training accuracy is almost 1. But the problem is here. The problem is here. We have training loss, validation loss. Now training loss is decreasing. You can see the training loss is decreasing a lot. That means our data is getting trained very well to the training data. But what has happened to the validation loss? Validation loss is increasing. That is the problem. That means what is the problem here? Now, if I give you a plot like this and ask you to detect the problem in the exam, then you should be able to identify. Now, this is a classic example of overfitting. This is a classic example of overfitting because you are fitting very well to the data. You are fitting very well to the training data. So there is like almost no training loss towards the end. Like training loss is reaching 0. But if you use that model to validate your data, your loss is going up, like it's increasing. So that means you have overfitted to the training data so much that you have lost the generalization. For general data, you cannot predict accurately. That is why your validation loss is increased. So that means we have to do something to make sure that our validation loss is also decreasing with the training loss. So if our validation loss followed the same path, then our model would have been much better. But the problem is this is increasing while this is decreasing. So we can do 2 things. mainly there are two main tactics. One is the augmentation that I told you about, data augmentation that we talked about last time. And the other one is, can you remember the other one? So if you look at what we have in this network, what is missing here? Now we have convolution, we have max pooling, we have flattening, we have dense. There is something missing here. Can anybody tell me? One type of layer we don't have here. Anybody? We don't have the dropout layer. We don't have the dropout layer. And also we didn't do the augmentation. Augmentation means for a given image, we can rotate it and shift it horizontally, and we can make it look like this one image is like 6 images, so that we can increase the size of our training set. So data augmentation is specially done when we don't have enough images. Here also we have around 3,000 like images altogether. For 5 classes, we have around 3,000 images. So that means like for a given class, we have around like 800 images, right? Not even 800. Yeah, around 800 images. Like that is 800 into 5, like we have like 4,000, right? So that is not, most of the time, it's not good enough for a given class to give very accurate predictions. We have to have like thousands and thousands of images. As we have more and more images, our accuracy will most of the time increase. Okay, more images, the better. So one way of increasing the number of images for training set is data augmentation. So the other fine tuning we can do to this model is having data augmentation and having a dropout layer. So we can see what will happen when we do that. Okay. So what will happen, do data augmentation, and so that is what we are going to do later. Now, this is data augmentation. Okay. Now, in the latest version of TensorFlow, data augmentation can be added as a separate layer to the neural network. So that is another change here. You can see now this was not possible in the previous versions. But in the new versions, this augmentation can be added as a separate layer. Okay, so here we are going to do random flip, random horizontal flip, random rotation, and random zoom. Like to which extent we are going to do that is given by this number. Okay, so that means we are going to increase the size of our training data set by doing these processes, this randomly flipping the images, randomly rotating the images, randomly zooming the images. Okay, so those are the things we are going to do. Okay, now we are going to just visualize what we have done. Visualize what we have done by those activities. Like by doing those activities, that means this data augmentation. What have we done actually? So I'll just remove this part. Just remove this part. So what do we have here? So we are going to take a set of data from this augmented images. See, here we are going to augment data augmentation, and then we give our images as the input. Okay. So then we are going to see what they really look like after augmentation. You can see what has happened. So for a given image, we have this like at different angles. See, we are rotating them randomly. So now instead of one image, now we have 6 images. So this is data augmentation. Okay. And the other thing I said was applying the dropout layer. Dropout layer means you randomly switch off certain a given percentage of connections between nodes. You randomly switch off. So in this case, you randomly switch off 20% of the connections between nodes. That is dropout 0.2. You know, you already have added the data augmentation layer here. Data augmentation layer. And then you have rescaled the images. Then you have the convolutional layer, max pooling layer, again convolution, max pooling. Then before flattening, you have a dropout layer of 20%. Okay. Now again, we are going to compile it using Adam as the optimizer. And just like before, sparse categorical cross entropy. That is the loss. Accuracy is the metric. This time we are going to use it for 15 epochs. Okay. So this might take again some time. So this is the summary of our model. And it's going to start the epochs. So in the meantime, you can check out this website, teachablemachine.withgoogle.com, which is a really nice website that you can use for like if you are making certain models with your mobile phones, for example, you can easily do this. So it's very easy actually. You can just have to click get started. Get started. So this what this did you see that like what that girl did in some of the pictures? She has a dog, and the other one there is no dog in the picture, only she is there. Then it can identify whether the dog is in the picture or not. So you can do it like using the webcam. That is the cool thing about this. You don't need anything else. You can just do it using the webcam. So you can just say like start an existing project from Drive, or that the different options. So there is image project, and if you are going to pose for the camera using the webcam, that is also available. Like if you want to show some signs using your hands and legs, that can be done. Here also like two options are there. Here we have the standard image model and embedded image model. So this is best for microcontrollers. Microcontrollers means you have this Internet of Things gadgetics like Raspberry Pi and Arduino and things like that. So actually Arduino is a microcontroller, Raspberry Pi is a computer. So for that you can go in this path, but for the rest you can follow this path. So model size is going to be around 5 MB here, but here the model size is going to be very small because you can't have like huge models in tiny hardware gadgets like Arduino or Raspberry Pi. Okay, so this is going to be the normal one if you are going to use the laptop or something. So then you have two options, like whether to use your webcam for the images or upload the images. So if in our case now, we can now we have five types of flowers, right? 5 types of flowers. So we can upload them. So I mean, we can even do like a pose for our camera using the webcam. But if I use the webcam now, then I can't record this thing, right? So that is the problem. But you can try it like at your home using this webcam. You can very easily create some models. Okay. So we will give the samples using upload. Okay, so class 1, class 2, but you can add any number of classes. So in our case, we have how many classes? We have 5 classes. So we can say add class, okay? So we can just do like, we can even like by default, this one is class 1, but we can call it roses. Okay. Or just roses. Okay. Here we can call it, what did we have? Like we had tulips, right? Tulips. And then we can add a class. Dandelion or something like that. Another one. So I think we have, yeah, these are the flowers we have. Dandelion, sunflowers, and daisy. Okay, sunflowers. Sunflowers, and then daisy. Okay, I'm gonna call it daisies. Anyway, okay, now you just have to upload them. But I mean, if you try to upload a lot of files, then it might take some time. But if you can just have only a few of them, okay. But if we decrease the number of images, then like for example, this folder has like how many? 633 items. 633 items. So we can try. I mean, one image is like only 20 kilobytes. So it won't take that much time. So we can just try. We'll just try, okay? Choose images from your file. So drag and drop here. Okay. So we can just drag and drop here. So we can just go to this daisy and we have what process, right? Process. So we can just control A and then just drag them here. I mean, it might take some time depending on the internet speed. Actually, you know what? I think I missed a trick here because I uploaded everything. But it's okay. It's okay. Okay, now uploaded everything. 641 images. Okay. So that's it. And then for the tulips, you can upload from here. Mm, mm. Yeah, so now we go to tulips. Control A. These are very small images, like only 20 kilobytes, like one image is, otherwise it will not get uploaded this fast. Okay, now we have tulips. Now upload the dandelions. So just like before, it's very easy. I mean, you don't have to write any code or anything, just visually drag and drop. Actually, I'm not sure how long it will take for this model to train. Okay, I mean, we are just uploading them, but depends on. So we have two more models to go. Two more types of flowers to go. So sunflowers. If we only have like 100 images from each class, then this would be very fast. But I don't know. Let's see. Now we finally have daisies. Okay, now we are done with that. Now it's time to train the model. Now, if you want to tweak the model a little bit, then you can go to the advanced features. By default, it's 50 epochs. But if you feel like you cannot wait that much, then you can bring it down to like 20 or even 10. We can just check how it works, because I don't know how much time it will take. Let's try 15 and see. And then batch size is 16. Learning rate is like the gradient. It's like if you increase this too much, then you are going to miss the minimum. Okay, I mean it's good to have a small value for learning rate. That means how fast you are going down in terms of loss. But if it is too slow, then it will take too much time. If it is too high, then you might just keep on moving around the minimum without actually reaching the minimum. You must just jump out and then again jump over the minimum, again jump over the minimum, because your jumping distance is too much. So this is a good value, like not too high, not too low. Okay. Now we can try training the model. Now it is training. It says preparing training data. Yeah, I mean, during that time it says page unresponsive, because now it cannot take any response from us because there is a lot of action going on behind, right? So it is definitely going to be unresponsive. But you should not exit the page because you know there is a lot of calculations going behind the scene. So just wait. Okay? You just have to keep waiting. So yeah, just say wait all the time. Just wait. Because although it looks like it's not doing anything, it is doing something. The only problem is like it is not reporting any progress, like intermediate progress. So we feel like going somewhere and having a tea and then coming back. I mean, that's good. Okay. So once it is done, it will tell you like it has been trained here. It has been, the training is done. Then you can just export the result. It's easy. I feel like you guys are gradually losing interest. So anyway, because our model is still running actually. So I'm just yeah, I did one mistake because I was messing around it with too much this GPU last night, that I lost my quota. So I will have to wait for another couple of hours until they give me back the GPU. So now you see it's when it is only CPU, it is quite slow. But the GPU is extreme, like it's very fast. It will only take like 2-3 minutes to run this whole thing. So in the meantime, we have this teachable machine as well. We will see how it goes. But this time, this model is quite big. That is the problem. So what else do we have? The interesting stuff. There is this one called Deep Lizard. Deep Lizard. Okay, Deep Lizard or Deep Lizard. That is another one. Like, it's a good one. You can use this one. This has also many free resources available. Some of them are not for free, but many of them are for free. Okay. So you have some courses here. Browse deep learning courses. It is still loading. So there's beginner machine learning and deep learning fundamentals. 36 videos. So there are basically 3 courses. And just click on the course details. So everything is explained here. So I think all of these are like free. You can just say start now. Yeah, everything is like free. Artificial neural networks. And I think you even have convolutional neural networks. Everything is here. And the backpropagation algorithm, which is supposed to be like a daunting algorithm. I think it's explained here, like from scratch. And even the CNNs, the convolutional neural networks, explained. I just click, yeah, data augmentation. You see, one hot encoding. Yeah, today it takes a ton of time to load. Yeah, it's just can just start watching that.
In this video, we'll be discussing convolutional neural networks.
Can you guys hear what she's saying?
Application problems as well. Most generally, we can think of a CNN as an artificial neural network that has some type of specialization for being able to pick out or detect patterns and make sense of them. This pattern detection is what makes CNN so useful for image analysis.
Things happening.
So if a CNN is just some form of an artificial neural network, what differentiates it from just a standard multi-layer perceptron
Oh, this is that. Things have gone down. I think it's better to put this on YouTube.
or MLP. Well, a CNN has hidden layers called convolutional layers, and these layers are precisely what makes a CNN.
Yeah. So you know the link. Just go there and see. You know, deep learning. Not moving. The mouse stopped moving. This is only a 8 GB RAM machine. So I think I might have to kill this page.
Now, CNNs can and usually do have other non-convolutional layers as well, but the basis of a CNN is the convolutional layers. All right, so what do these convolutional layers do? Just like any other layer, a convolution filters the layer should have, and we'll speak technically about what a filter is in just a few moments. But for now, understand that these filters
Hello guys. I think this, guys, can you hear me? Hello?
Yes, sir, we can hear you.
I think this teachable machine is using a lot of our resources. I think that is the problem. It is happening on our side, actually. I think it's using our RAM, probably. It's happening on the client side, I think. I think that is why we have some of these problems. Otherwise, see, the skill 0 out of 15. Still, now it is in the training stage, but we lost the connection actually. We sort of lost the connection. So anyway, actually I have, oh, this has even 15 or it just finished running. Still connecting. Okay, now it's connected. We might have the data. I mean, not sure if the data has disappeared or not. So we have basically run up to this point. We can just check whether everything is okay or not. If the data has been erased, then you're out of luck. Okay. No, the data has not been erased actually. Now you can see here. Now the only thing we did was we created the dropout layer and we added the data augmentation. That is the two things we did. We added the data augmentation. That is, we randomly flip, randomly rotate, and randomly zoom in and out. So looks like this. Different rotations. Now this one is like zoomed in. This is like zoomed out. So other than that, we added the dropout layer. So those two of those actions were taken to prevent overfitting of the data, prevent the overfitting of data. So now we can see how the accuracy looks like. You can see now the accuracy reported is not as high as before. I mean, you can see here. Accuracy reported is around 80%. See, 0.7943. 0.7943. But what is good about this model is training loss and validation loss. You can see the validation loss has also gone down. The validation loss has gone down with the training loss. Earlier, what did we see? Earlier, we had a problem. The validation loss is going up while the training loss is going down. Here it is different. Here we have both of them going down. So you can see the effect of the dropout layer and the data augmentation. So it reduces the amount of overfitting to training data. It prevents that. Okay. So many people calling at the wrong time. I don't know who these people are, but if it is some guy from the university, then it's not good. So now you guys understand the difference now. The difference that was created by adding a dropout layer and what? And the data augmentation. So that is the idea. I just wanted to show you the power of those two simple techniques. Okay. Now the model has been trained. Now the other important thing is how can we download the model? So how do we download the model? So if you want to download the model, how can we do that? You can just check in the internet. So there should be something called a save model. Keras. Okay. Save model. Save model. See? Save and load model. So this is straight from TensorFlow. Okay, so from their website. So how do we? So this gives you everything like defining a model, saving checkpoints. Okay. Checkpoints means like you're saving intermediate results. Like while the model is getting optimized. Okay. Now save the entire model. That is what we are looking for. Save the entire model. Okay. Yeah. So how do you do that? See model.save. Model.save, but we are not looking for that. We are looking for saving it in the HDF file model. So here you can say model.save, save the entire model. That is how you save the model, model.save. So you can go here and try that one. Model.save. We will try that. Can we flower detect v2 dot hdf. Let's try that one. Okay. Now where do you save that one? Because during that time we lost the connection. Maybe I don't see it. Just yeah, I can't see any file saved here. Hmm. Oh, okay. Now we have it. Oh man. Now we have this HDF5 file that contains everything that the whole model that we created. Okay, we can just download that file. Okay. So once we are done with that, we can just say model.save, and then it will get created in the temporary files directory. Sure, it's right. It's not here in the temporary. Yeah, we were looking at the temporary folder. Yeah, it was not created in the temporary folder. That's it. Okay, now it's downloaded. See, I mean, if you want to create it inside the TMP file, we can just say TMP and here. Then it will go to that place. Now we can go to the TMP. Should be there once we, yeah. So then it will get created here inside the TMP folder. Then you can just right click and say download. Okay. So now our model is ready, and finally. Okay, now what's going on here? This. Okay. Let's close this one. Now it's time to test. It's time to test the model. Everything looks good. Now we have to test something. So how are we going to test that? So we have to give it some files. Give it some files. Okay. So this is the last bit of code that is required in order to give out the test result. So this is where we give our image. We give the image, and that image will be automatically, it will be resized to the 180 by 180 pixel size by giving the target size. So we are using keras.preprocessing.image.load image, and then the image location, and then the target size, which is the size to which the image will be resized. Okay. Then after that, it will be converted into an array. So just like last week, it will be first converted into an array. And then we have to expand the dimensions from 3 dimensions to 4 dimensions. Okay, so we have at the beginning we have 3 dimensions. Okay, so we have to add a further dimension to include the batch number, because TensorFlow always requires the image to be in the tensor format. It should be not having 3 but 4 dimensions. Okay. Okay. So image height, width, and RGB, and then the batch number. Like inside the batch, what is the number? Okay, so we have to add that other dimension. Then we can give that as input to the model to predict. Okay. So what did we do? We first read the image, resized it, and then converted into an array, added another dimension, like expanded the dimension, gave it as input to the model to predict. Okay, then it is going to use softmax to do the predictions. Prediction 0 means like it is going to have the highest score. In the softmax, the highest score. What is the item with the highest score? Then you have to print this image most likely belongs to then braces. That means this will be replaced by class names np argmax score. Okay, that means we have to find the argument, that is the for this score. Now this is the score, right? This is the score. For that we have to find the index. Argmax means the index of the maximum value, and then the class name for that value. That will be replaced. That will be replacing this brace, this first brace. This first brace will be replaced by this one, and this second brace, it has this 0.2f. That means give it to 2 decimal places. 0.2f means give it to 2 floating point. That means 2 decimal places. Okay, so the probability will be given to 2 decimal places. What is the confidence? With what amount of confidence are you predicting? And that will be calculated by multiplying the score, okay, by 100. np.max score, the maximum score out of the scores that we get for each class, multiply that by 100. 100 means we are going to give it as a percentage. Okay, we are going to give it as a percentage, the probability. Okay, so now we can give some images. So any image, we can find any image that we want. Just type whatever you want, like I mean, they should fall into one of these classes. So any, like there was this flower called dandelion, right? So we can just Google dandelion. So it is something like this. So we just pick any image we want, like let's say let's go to images and pick an image. Yeah, it's going to take some time. Okay, let's say, yeah, which one do you want? I don't know. Let's pick this one. Or even this one. This one. Okay. So it is loading here. Okay, now we say view image. View image. Now you have the, actually this one is this will be, let's try this again. Okay, yeah, this is the image. So we just copy this URL. Copy this URL. Actually, you know what? Just download this one. So save image as, and we will give it to the this folder. Okay. Save. And now we can upload it here. We can upload that image here. This is losing connection all the time. Allocating. No, I don't need what. Okay. Now let's upload something here. Temporary folder. We can upload something here. Right click and upload. So we can give all of this. Like, I mean, I had some initially. I had downloaded some others. So this is the one we downloaded, right? So close up of a dandelion. We can even give the other ones like here. This one, this one, this one. Can just give them. Yeah, I mean, they will be deleted once this runtime is finished. So we know that. So they are getting uploaded. Okay, the upload is finished. So we just pick one of these. This one is the one that we wanted. So copy path. So we are going to give that path here. Okay. So let's hope we will get, we don't have to hope, like, let's see. This, yeah, see, it says this image most likely belongs to dandelion with a 71.32% confidence. So that is a dandelion, we know that, right? So we can give another one, like you can download another one from the internet. Dandelion. Did we have in our pictures, in our data, what did we have for dandelions? Oh yeah, we have this yellow flowers as well. And let's pick a rose actually. You know what? Now we already picked. So let's pick a rose. Okay. Now there is one here. Let's view this one. What happened to that image? Okay, this one. Let's use this one. Let's just save this one. Okay. Then we upload it here. And this is getting really annoying. Okay, now let's upload that one as well. Oh, this is a yellow one, but yeah, I mean, I don't know whether we only train for the red ones, but let's check. Because if we only train for the red ones, then this might not be accurate. Yeah, that's the problem. Now this one is Now this is for the previous one. I mean, sometimes this can go wrong. That is why it's only 80%. So if you predict for 5 of them, 4 of the predictions will be correct and 1 will be wrong, right? So this is the tulip. So that is correct. That one is for what is that? Yeah, it is this one. So this little girl is in a like garden, like a tulip garden. That is that photo, deposit photos. So that is this one. So that is tulips. So that is correct. But that yellow colored rose, that was not identified correct. Yellow colored rose was not identified. So probably we didn't train for the yellow roses. Oh, there are yellow ones. Yeah, but somehow it couldn't understand that. Mhm. It fails for that one. So it doesn't doesn't identify that. But any other rows we can check. Yeah, just pick one of these, like so. This one. Yeah, that one was identified as rows. See, that one was identified as rows. So, I mean, it's not that bad. I mean, so we checked for like a couple of them and only one went wrong. Actually. So, yeah, belongs to Daisy with 100% confidence. So the model is not bad. I mean, it's very rare it's predicting wrong, but most of the time the predictions are correct. Okay. So here it's only 80% accuracy, right? So that's about it. With what's going on with our teachable machine. Okay. Yeah, it's quite slow, guys. I mean, this is a huge model, right? It somehow finished. Okay. Actually finished four of them. Oh, now it finished 5. Going pretty fast now. 6. I don't know what's going on. It's like going at express speed now. 8. Maybe you should have given only 10. Okay, 11. Only 4 more to go. Okay, 3. Okay, done. Okay. Yeah, there was an error opening your webcam. Okay. Otherwise, I could have shown the rows through my webcam. So anyway, we can just export the model here. Export model. And there are like a couple of options for us to export the model. Okay. So this is the model given in like JavaScript. Like if you want to embed in somewhere, you know. And also you can just This one, TensorFlow Lite. TensorFlow Lite is for mobile phones. Like if you want to use it in some mobile device like Android, okay, Android version. So you can just download this one. You can just say download. Okay. Got stuck again. I only click the download button. Today is such a slow day. Come on. So anyway, I mean, I have downloaded models from this one before. So this is what you do. I mean, whatever the version that you want, you select that one and then you can just download. Okay. Just converting model. To enable your model in the app, switch the active model to quantize mobile net. So there are some instructions given here. For this teachable machine example, the quantized TF-Lite model is being used. If it is using the TF-Lite Android example, note that the example only supports models with 3 or more classes, even though the classifier itself in the example supports 2. Anyway, so it is still converting the model. Converting your model in the cloud, this may take a few minutes. So now, okay, now see, it got downloaded, converted tflite.zip. So the model got downloaded. Yeah. So you can use it in any other device. Okay, now this is for computers, especially like, for example, in our case, this will download in the HDF file. So this is H5, see, H5 model. You download it like that. Okay. So we can image upload. So we can upload a file here. Choose images from your files. Okay, now we can go to this folder and just put it over there and see what it says. Let's put this girl there. Nothing happened. Let's see. So it again started like very slow now. Maybe I'll just stop sharing. Okay, the output came, guys. I mean, yeah, because it takes a little bit of resources. Are you guys there? Can you guys hear me?
Yes, sir.
Okay. Yes. Just waiting. You can see. Can you see now? My screen?
Also, it's still loading.
Okay. Still loading, right?
Also, that didn't.
Now can you see? Okay, now you can see, right? Hello?
Yes, sir.
Now you can see now this was detected as roses because there are roses around this girl. See, 98% roses. So this one is also not that bad. This teachable machine, you can just do everything manually without coding or anything. I mean, as like food science students, like not a whole lot of coding is expected from you guys. Sorry. So sunflowers, we didn't check any sunflower. Check the sunflower here. This. Oh, what happened? I wanted to load it here. Did I just? Man, I think I accidentally closed that. Okay, guys. So anyway, now you guys saw the what can be done with this. I think I just wanted to close that image, but I think I accidentally closed that teachable machine thing. Know what happened, but I think yeah, that's what happened. I accidentally closed that one. So it's just a drag and drop thing. Yeah, now it's going to be a fresh page, so it won't remember anything. So anyway, you guys now know what can be done, and try to use this web page. It's very easier. I mean, just have to get started and say it's an image project, standard image model, then create a number of classes you want, then upload the images, train the model, and then preview. And at the same time, you can export the model as well. So you can tweak these parameters a little bit. I gave 15 here. So you can do it like that as well. Or else, if you want to code it and get some coding experience, which is really important, you can do it in this platform as well. You can see, like I showed you, how to download the trained model. So basically what you have to understand is these concepts. Okay, what is the convolution? What is the convolution layer? What can go wrong? What is the dropout? What is the why are we using a dropout layer? What is good about this model, and what is bad about the previous model? Like if I give you like compare and contrast, like what is bad about this one? Okay, in the exam I can ask for your comments. There is something wrong with this model. What do you think? Comment with the 3-4 sentences. Okay, and what is this technique? Okay, you know that it's augmentation. So those are the concepts that you have to identify. And now these techniques, if you have some knowledge, you will definitely have an advantage about your other competitors. Like not all the people have an exposure like you guys about this state-of-the-art techniques, these machine learning things and deep learning things. Now you guys know what they mean, right? So what is a neural network? Okay. So okay guys, that's basically what I wanted to teach you guys during this series and show you some really cool tools so which we can use. Okay, so you saw that this platform is really important. Without installing any software, you can just start using it for free. Okay, this collabs platform, which is very useful, and also that teachable machine, they're totally free. So whenever you have time, you can use them, and if you are interested in doing research using those tools, you can come and meet me, and we can talk about it, and we can start doing some research. Okay. So thank you very much for your attention, guys. So there's a question. Something wrong with that text. I can't see that text, guys. Like, is there something wrong with that?
I asked for the codes of the programs we wrote last week and this week. Can you share it with us?
Oh, yeah,
Please.
sure. Yeah. And I think at the very beginning, there was a person asking for the share request for the. Oh, yeah, this IPython notebook. Okay, sure. Yeah, I will send that IPython notebook and the code and everything. I will send you links. So to whom I think. So do you guys have any like a representative or somebody? Because even these demonstrators, they are changing these days. I don't know. So if any one of you just if you can send me an email. So this person, she has sent me an email, right? So I can send her everything. Then you can, I think, get it from her. Chamali Vijay Gunawardhan, are you there? No. So she has asked for that item. So I can send Amila Nuan. Amila Nuan, are you there? No?
So they are not from our batch, I think.
Oh, okay. So just send me, if you send me an email, then I can easily respond to it, and then you can, all of you can share what I send you. Because I have not been added to that this course in the LMS. So I cannot upload the content there. So, but I can, because the previous demonstrator, I think she has reached the end of contract or something. So there's a new demonstrator. So once I get to know her, I mean, once I get to know her email, then I can send it via her. If you want it before that, then just send me an email, then I will send it to you. Is that okay with you?
Okay, sir.
Yeah, just send me an email. Okay, guys, then it has been really nice, and it's a good experience. Always you learn new things, because this is changing all the time, right? Like within 6 months time, so many things can happen in this deep learning, machine learning field. Everything is changing all the time. So you have to, if you are interested, you have to be like always very vigilant, like keep an eye for all the changes. Visit TensorFlow website, see what is going on, what are the latest changes. So keep yourself up to date, and these techniques always have so many applications. So even when you go to a interview, like in the future, there will be so many applications of data science. Okay, so definitely you will have an advantage above your competitors if you have knowledge about data science and machine learning, deep learning. Those subjects, they are of very high demand in the future. So thank you very much for attention, and if you have any questions, just email me. Okay, so you guys have a very nice evening. So I'm gonna bid goodbye. Okay. Okay, thank you guys. Okay.
Thank you, sir.